Okay, I hope you all can see that. So we can talk a little bit about the basic structure of blockchains. So blockchains, in its name, are a chain of blocks. So each block is attached to the last block, and then the next, and then the next, and then they form a very, very long string of blocks. And essentially, there's a few main characteristics of blockchains that set them apart from traditional payment systems or traditional centralized systems. So first one is peer-to-peer. Now, what does that mean? So think I mentioned that blockchains are decentralized, meaning that they have no central authority. So with or no third party. So whenever you engage in a transaction, the transaction is only between you and the recipient of whoever you're sending the money to, or whoever's sending money to you and you. So it's only between you and the other person, peer-to-peer. That's what it means. And so, as I said before, think of it as a black market transaction that nobody knows, but you and the other person, except it's legal and verified. So if we think about it, right, if you do even a cash transaction, it's still centralized because there's a central bank that prints the money and controls the money supply. So blockchains actually allow true transactions with no central allows transactions with no truly no central authority. It's just between you and the other person. That's what peer-to-peer essentially means. And next is immutable. Immutable just means unchangeable. And what this means is that data and transactions of blockchains cannot be changed. So, for example, transactions in the past that were logged on blockchains, or transactions that were, or like, for example, like the transaction data of people that were logged on blockchains cannot ever be changed. So I can see, like, you can look at the transactions that happened before on a certain blockchain, like, for example, the Bitcoin blockchain. You can look at all the information on the Bitcoin blockchain from however long since its creation, and it will be unchanged. And we'll discuss why this all works briefly in this class, and also mainly in the next few classes. So third is distributed. Distributed essentially means that the data and the security process of blockchains are distribute like the responsibility of that are distributed to every single device or node that participates in the blockchain. So when you think about traditional currencies, like for example cash, or even like digital currencies, like online banking, they're all stored in one place. So for example, a bank might store your money. You might have a safe in your house that has some money, and they're only secured in that one place by that one authority, central authority, being the bank, you, or the government, or something like that. Cryptocurrencies are actually technically stored by every single device that participates on the blockchain. So, for example, if we're all on our own blockchain, let's call it the Eric blockchain, then my money is secured through validation processes by every single person in this meeting right now. So what that means is if I were to, for example, engage in a transaction, send some money, then everybody in this class will have a record of the transaction, and B, be responsible for actually verifying that transaction. And that's not something you really see in traditional systems. And lastly is ledger. So a ledger is basically a book or something of the sort where you list down all the transactions down. So something like at 7:29 p.m., Eric sent $20 to some person. At 7:10 p.m., somebody sent $10 to somebody else. That's basically what a ledger does. And blockchains are ledgers in that they note every transaction down and organizes them. And the interesting thing is that every single transaction is available for anybody to see. So, of course, you can't see the personal information of the sender recipients, but you can see, like, for example, the amount. You can see all sorts of different data on the you can see all sorts of different data publicly available for the blockchain. And I can show that right now. Basically, Blockchain Explorer is just a site that has blockchain information. And I can choose any single blockchain, public blockchain, like let's say, for example, Bitcoin. I can see all the blocks. I can see all the blocks of the blockchain. So right now we're at 869,517. And you can see that each blockchain is block is linked to the last, the one before it. And let's just pick the second last one. And what happens is that all of the information that ever happened with the blockchain, so every single transaction and the information related with that transaction is noted down on the blockchain. So let me just quickly explain the basic structure of a blockchain. So there's many transactions on a blockchain. And what happens is that all these transactions are grouped together into these blocks. So these blocks. And each block will have a certain number of transactions depending on how the blockchain is coded and the algorithm works. And these transactions are grouped into these blocks, and these blocks are connected to one of each other. So this also plays into why blockchain is immutable, because every single block like recursively references the last block. So this block references this block, this block references this block, this block references this block. So in order to change some data in a blockchain, you have to change every single block before it and after it, which is essentially impossible given to the size of a blockchain. Yeah, hopefully this can load in a second. Give me a second. Okay, there we go. Okay, so now we can discuss briefly on the usages of blockchain. Okay, so I gave 3 examples here, which are first is supply chains. So in supply chains, in supply chains, you're required to have massive amounts of like data management. For example, in a shipping company, they need to manage the data of their of what they send, what they receive, and logs of everything that passes through their company, right? So now with a blockchain system or a blockchain structured system, so it doesn't have to be necessarily exactly like a blockchain, but with a system structured like a blockchain, shipping companies or any like supply chain company can store the data of every shipment or something like that on an open ledger without the fear of tampering. And secondly is data storage and management. So similarly, large amounts of data can be noted in a ledger like blockchain. And lastly is helping to shape Web 3.0. And another thing about blockchains is that they are 100% transparent, secure, and censorship resistant. So in the website I just showed you, I was able to see all the data correlated with a blockchain. And I was also able to see all the transactions that goes on the blockchain. And I was able to see the data like that. I was able to see the data, the information related with those transactions. So that makes blockchains actually 100% transparent. Obviously it won't like give personal information like the keys of like people, but it will be able to show all the information that is required to be transparent. Next is blockchains are secure. So as previously mentioned, blocks all reference the last block, and that makes them secure and intamperable. And lastly, they're censorship resistant. because of the way blockchains are built, there's actually no way to prevent people from seeing the data or the information on blockchain. So there's no way for people to, for example, like the government, for example, cannot say, oh, now we're going to restrict all the information on blockchains to only like the government individuals or something like that. Because all the information on blockchains are publicly visible, not just necessarily through the website I showed, it cannot be necessarily censored. And so for example, an analogy to this is a bank cannot disclose the reserves it has or the money supply or the money that it holds or the bank accounts of people without jeopardizing everyone's money. But blockchains can actually show all this information while still being secure and safe and secure. And obviously that comes with some pros and cons. So this is what we're going to discuss right now. So first, what are the good things about blockchains? So we just mentioned that they're 100% transparent, and they're censorship resistant, and they're also much safer than traditional systems in that they're less likely to be tampered with. Now, of course, those benefits do have to come with cons, and the main cons and the main downsides of blockchains is that number one, they are definitely slower, because they are definitely slower. So because of the algorithm that they have to run in order to actually process the transactions, right? Verify the transactions. Second, they require more electricity and power because of their verification system, which is at least some of them, which is proof of work and crypto mining. They require high amounts of power and electricity to actually fulfill the requirements for validation. And lastly, there are high costs associated with blockchains. Typically, when you send money, there's a transaction fee, and that's called gas fees on blockchains, and they're especially high. Sorry, let me just respond to a message in chat.
So, there have any loophole in this block system?
I wouldn't say there's any loopholes. Like you can't really, like for example, hack a blockchain or steal data from a blockchain. Of course, there has been like attacks, like for example, on blockchain exchanges, but that's not to do with the blockchain itself. It's to do with the exchange. So I wouldn't say that there's any like found way, at least that anyone like there's no way that anyone has found to actually hack a blockchain itself. But there's definitely ways to there have been definitely been events where like blockchain exchanges or people's computers have been hacked or like exploited, if that makes sense. There we go.
Got it.
Oh, sorry. Go ahead. Okay. Um, okay. So, oh, before we get to the end, I actually have some notes I want to say. Uh, okay. I just have some last things I want to say. So first is specifically about being slower. Just to put this in context, they're a lot slower. So for example, Bitcoin blockchain has around 7 transactions per second. So of all the people around the world, it can only handle 7 transactions per second. And that's also a reason why the gas fee is so high, because the blockchain can only handle so many transactions at a time. So it ends up that each transaction costs more of the blockchain's time, so it has a higher gas fee. But yeah, Bitcoin blockchain can only handle 7 transactions, while Visa can handle over around 60,000 transactions per second. So if you just compare the two numbers, it's obviously very, very different. And that's just due to the decentralized nature of blockchains, where you have to go through the proof of work algorithm in order to verify transactions, and that's what make it so slow. And on electricity and power, yeah, there's a lot of electricity requirements for supercomputers and data centers to process and verify the transactions. Um, two things I want to mention as final notes. Is first is creating crypto wallet. So when I first in the poster I first mentioned that I will be giving 50,000 Shiba, which is a type of cryptocurrency, and it's not a lot of money, but it's just something for fun. So what you need to have in order to actually receive any crypto is a crypto wallet. So this week, one of your tasks I would like is for you guys to see if you can actually find out and learn how to create a crypto wallet. So a hot wallet, which is an online wallet, is fine, or a cold wallet is also fine. But just see if you can create a wallet as a fun challenge. If any of you are having trouble, just email me or I'll go over it next class if you would like. And second is I will also like to have, along with just this course, an investing game that's just for fun. So I'm going to set up an investment simulator this week, which is basically going to give you virtual money, so fake money, and it's going to get data from the real market, real crypto market, and you can trade crypto on there. I'm gonna set it up by next week, and I'm going to introduce how to enter it, how to join the rules, and etc. next week. So are there any questions?
Yeah, so we're going to make
No.
a creating a crypto wallet today, like after this class.
Yeah, so one of your like sort of investigative tasks or fun tasks as homework, not really homework, but I think can do if you want, is to see if you can create a crypto wallet. And if you send your address, figure out how to receive crypto and send your address to me, your wallet address to me, I'll send you some crypto. It's just some fun thing to see if you want to do it this week.
All right, gotcha.
Okay, so that's the end of the first meeting. Thank you guys for coming. If you have any questions, just email the email that I put on the poster, as well as the one I just sent in chat. They're the same one. So just email that, send an email with your question. Just maybe put the subject as like a question about crypto or something like that. And then I'll see if I'll try to answer as quickly as I can and to the best of my ability. After this class, I'll also email you all a review sort of sheet. It's just to help you review like what we went over today and not forget anything. You like I'm not expecting you to like fill it out and send it back to me. It's not really homework. It's just some questions you can take home to think about after this class to sort of remember what we talked about today. So that's the end of the first meeting, and yeah, see you guys later.